We have given function f, and our f function has three parts. For x less than or equals -3, we have constant function equals -5. For we have absolute value of x less than 3, we have 2x minus 1. It means we have linear function. The graph will be straight line, and because the coefficient before x is positive, our line is increasing. For x greater than or equals 3, we have 1 minus 3x. Again, we have linear function, and because the coefficient before x is negative, our line is decreasing. So, first I will take this absolute value, and based off rules for absolute value inequalities, if someone forgot, absolute value of x is less than a, it means that x is greater than -a and less than a. So in our case, we will have x is greater than -3 and less than 3. So we can draw x axis. We have -3 and 3. X must be greater than -3. But -3 is not included. Greater than -3, it's going to positive infinity. And less than 3. So we see that in the second case we will have interval from -3 to 3. X belongs to interval from -3 to 3. So for 2x minus 1, we will draw straight line only for x belongs to interval from -3 to 3. So before we go to graph our function, we have to write the domain. Our x belongs, we see, for x less than or equals -3, we have constant function equals -5. For x belongs to interval from -3 to 3, we have line 2x minus 1. And for x greater than or equals 3, we have to draw the graph 1 minus 3x. So our x belongs to all real numbers, we can write. So this is our domain. Now I will divide our function f to three functions. f1 of x will be negative equals -5, and I will draw this function for x less than or equals -3. The second, f2 of x, is equal to x minus 1, and I will draw this function for x belongs to interval from -3 to 3. And the third function, will be 1 minus 3x, and this function will be only for x greater than or equals 3. First we will draw our first function f1. This function is constant. All values are equals -5 for x less than or equals -3. So let me draw xy plane. Y equals f of x and x-axis. Now we have to choose the unit. 1, 1, -1, -1. we have x less than or equals 3. So let's find negative 3, negative 2, negative 3. And for all this x, we have value negative 5. So we have to find the value negative 5, negative 2, 3, 4, 5. And we have to start draw straight line parallel to x-axis, and this point negative 3 is included because we have sign x is less than or equals negative 3. So we have line parallel to x-axis. This is our first function. Now we will have to draw the second. We have 2x minus 1. So the graph for this function is straight line. Because we have positive coefficient, it means our line is increasing. And we have to choose x from this interval. Like always, we will check how this function behaves on the end this interval. So I have to choose negative 3. I can choose 0 and 3. So let me draw the table. We have in first row x. In the second we have f2 of x equals 2x minus 1. First we have to replace x by negative 3. So we will have 2 times negative 3 minus 1. This is equal, 2 times negative 3 is negative 6, minus 1 will be negative 7. Now we will replace x by 0. So will be 2 times 0 minus 1. This is equal, 2 times 0 is 0, minus 1 is minus 1. Now we will replace x by 3. So it will be 2 times 3 minus 1. This is equal, 2 times 3 is 6, minus 1 will be 5. So we have 3 points. Let me write this. Negative 3, first coordinate. The second is negative 7. Now we have 0, negative 1, and 3, 5. So now we have to find these 3 points in our xy plane. So first point is negative 3, negative 7. Negative 3 and value negative 7. We have to go down. Negative 6, negative 7. Let me connect this. This is approximately negative 3. And because we have domain for our second function, open interval from negative 3 to 3, it means negative 3 is not included. So I will draw circle. Next point we have 0, negative 1. 0, negative 1. And the third is 3, 5. 1, 2, 3, 4, 5. This is 3. Let me connect this. This is approximately. And this point is not included in our graph because 3 doesn't belong to our domain for this function. So this is our point 3, 5. Here we have 0, negative 1. And we have negative 3, negative 7. Now we have to just connect these 3 points. So we have our second function. Now we have to draw the third. The third function has domain from 3 to positive infinity. So let me choose 3 value for x. So we will choose 3, 4, and 5. f3 of x is equal 1 minus 3x. So first we will replace x by 3. So will be 1 minus 3 times 3. This is equal 1 minus 3 times 3 is 9. So it will be negative 8. Next, we have to replace x by 4, so it will be 1 minus 3 times 4. 1 minus 12, it will be negative 11. And now we have to replace x by 5. So we have 1 minus 3 times 5. This is equal 1 minus 15, so it's negative 14. So we have 3 points, 3, negative 8, 4, negative 11, and 5, negative 14. So let's find these points. So first point is 3, negative 8, we have 3 and negative 8. It's negative 8. And this point belongs to our function because in the domain we have x is greater than or equals 3. So we have first point. Next we have 4, negative 11, negative 8, 9, 10, negative 11. So let me connect this. This is our second point. Here we have 3, negative 8. Now we have 4, negative 11. And the third point is 5, negative 14, negative 11, 12, 13, 14. So I have to move this paper. So we have our third point approximately here. Now we can connect these 3 points. We have straight line because we have function 1 minus 3x. The graph for linear function is straight line. So this is our solution.